Clinton Wolfe is going to be joining us. He actually came up here from OmniTI. OmniTI is a really cool company. And I say that because their founder wrote a bunch of books, right? Many of you may have heard of the term web operations. Show of hands, who's heard that term before? So Theo, the founder of OmniTI, he's the person who more or less coined that term. I'm sure it's a little debatable, but the first time I read about it, he was the person writing about it. And that was back when, before we were talking about things like DevOps. So I look at that term and a lot of the early practices as being when we began talking about the different ways we can automate and innovate with technology. So I'm really excited to have Clinton here with OmniTI. He actually leads the DevOps practice over there. So please join me in welcoming Clinton.
Hi. Is the mic on? Yes? All right, great. Before I start, I just want to point out that there are tiny pieces of tape all over this stage that just say the word horrors. So I don't know what that means. Anyway, so I'm going to be speaking about the maintainability of configuration management code. So I'm going to be using the word configuration management and CM a lot throughout this talk. And whenever I say that, that means things like Chef, Puppet, Ansible, SaltStack, CF Engine 2, if you're into that. All sorts of those sorts of things. All those sorts of tools are lumped together. They're called configuration management tools, and that's what I'll be talking about. And yeah, the question is, why does it all turn so ugly over time? If you've used it for any amount of time, you find that it turns kind of into a mess. So what can we do about that? So all right, first of all, a bit about me and my history. This is my senior picture from 1995. I am a very cool person, as you can see. The letter jacket is not a sports letter jacket. It is an academic letter jacket. You can tell that because the P is script. I got that for the math club. Anyway, that's from 95. I started programming in Perl in 1996, the next year. So my coolness level did not necessarily increase. Today, I am the lead DevOps consultant in OmniTI, and I'm a configuration management specialist. Especially, my focus is on Chef and Ansible. I'm not really going to talk much specifically about Chef or Ansible or Puppet or SaltStack and all this. They're all pretty much applicable to what I'm going to say here today. I'm really into software engineering, but for most of my career, though, I was a Perl web developer. So I was a mod Perl developer from 1996 to 2011, which you may notice, like 96 through like 2003, 2004 was like peak Perl. That was a big lot of Perl going on. That was how you wrote a web application at the time. 2003 through 2011 was maybe not, that's the back end of the tail on the Perl. But anyway, I learned, as many Perl programmers and other programmers found, that projects tend to start off green. You've got like, oh, you can do anything you want. You can define stuff. You can build stuff over here. You can use this module. And then over time, things turn brown. In other words, it's hard to extend things. It becomes inflexible, hard to maintain. When you hand it to someone else, they're like, oh my God, I don't know what I'm doing. This stuff is insane. So gradually over time, as I became a team lead and had to have other people maintain my code or code that others had written, I became a strong proponent of maintainability. Incidentally, this picture here, on top, that's me. And the guy in the bottom, who's that guy? Larry Wall! That's right. That was YAPC 2009. That was a great time. Anyway. So I became a fan of maintainability. What's maintainability? So within the Perl community, we started off with this attitude of Tom Towdy, or there's more than one way to do it. That was the Perl culture. So when you were a journeyman Perl programmer, as you were starting out, one of the first books you read was called the Camel Book. And literally, when you opened it up and you're like, how do I open a file? There's like a whole chapter on opening files. And they give you 8 ways of doing it. And like the latest edition has like 12 ways of doing it. So it's like, great, you really need that, right? There's just so many different ways of doing it. Creative freedom, implicit permission to do anything you want, to leverage the full flexibility of the language, that was the way to go. So that kind of led to a giant mess, though, if you ever needed anyone else to maintain your code or to use it on a team and to develop a real product. So a movement sprang up, as in many other communities, Perl isn't unique in this at all, to develop best practices. Now, when this book was published, it contained approximately 70 or so different best practices. And by the time it was physically dead tree in print, 10 of those best practices had been disavowed by the author. That's how fast it moved. But the whole gist of the movement at this point was no longer there's more than one way to do it, but rather there is more than one way to do it, but some ways are better than others. Finally, today, you would find this sort of book on the shelf, and that you'd find this sort of attitude, that you should stop doing all of those other things and just use this one proper way. And if in an emergency you had to go outside of the bounds and do some other peculiar thing, the language still allows you to do it. But there really is one right way. So we have modern Perl, and that is how a lot of communities mature. They go through a do anything you want to a, well, there's kind of a preferred way to a no, don't do it any other way. That everything else is insane. So getting away from Perl and speaking about maintainability in general, I like to define maintainability as and there's several different aspects to this, and I'll use a Jeep throughout. It's the ease with which a system can be interacted with over time in order to do various things. And I really want to hit that over time aspect in particular, because there's a lot of different aspects of software. There's flexibility, there's performance, all that sort of thing. But maintainability talks about its use over time. What's it like on day one versus what's it like on the day that the software is finally sunsetted? So one particular aspect that's important is the ability to diagnose problems. Now, World War II era Jeep is fantastic on this front, because there are few subsystems. It's obvious when one of them fails, and there aren't a whole lot of panels or anything that's hiding behind stuff. It's really easy to get at the problem and see what's going on. It's also easy to fix things. So if you need to make a repair to the drivetrain of a Jeep in World War II, you fold it in the rearview mirror and you flipped it on the side. That's all you had to do. So it should be easy to get at stuff and make repairs quickly. It also needs to be able to cope with changes in requirements. If you build a Ferrari and ask it to, oh, now I need it to go plow the field, you're going to have a really hard time. But a Jeep was built to be a very general use product. And it had attachment points in the rear deck where you could attach a number of different things, like a post hole digger, a number of other stuff, or a plow if that's what was needed. But most importantly, maintainability is all about maintaining useful life. Software is extremely expensive to develop. It's very labor intensive. And so because of this, we want to get as much return on investment as we can. So we want it to last as long as we possibly can, and these fine gentlemen are having a good time sometime in modern times in a very old Jeep. All right, that all sounds straightforward, right? We can just walk out the door and go do this. Of course not. So what are some of those factors that really affect the maintainability? Now, first I'm going to talk about application software, but we'll get to the configuration management stuff here in just a moment. So one of the major things that impacts maintainability is complexity. All software has a strong tendency to become more complex over time, but not all complexity is justifiable. So on the right, I think that's on the right. That would be the left. Slides are wrong. On the left, we have a Saturn V rocket performing the Apollo 17 mission, which its user story involved sending 3 people through space where you can die horribly in many ways, land 2 of them on the moon, bring them all home safely. Oh, and also bring a car with you and drive it around on the moon. They did all that, and they did it with as little complexity as possible, which was still an enormous amount of complexity. Now, on the other side, on the right, we have a device whose user story is open an umbrella. I think that's too much complexity to open an umbrella. So you might want to take a moment and consider the sort of goals and user stories that your software has, and consider, is the amount of complexity that you have realistic based on that? But why would complexity go up over time? Nobody wants complexity. Why would you make things like that umbrella opener? Well, things usually start off simple, but then you have to glue on a new interface because the product team decided on a new integration for marketing, blah, blah, blah. And also it has to be on mobile, and it has to make toast. So no design can anticipate all of those changes, and no design should. If you try to make a design that can anticipate all of those changes, you end up with something else that's horrible called Yagni. So things do end up getting glued on. Now, there's a lot of business pressure to add functionality, but there's rarely pressure to reduce that complexity or to take a moment and refactor things. Now, different organizations handle this differently. Some organizations have a strong agility movement within them that really brings forward this. We need to refactor occasionally in order to maintain agility. But it's really, really hard to communicate to the business that. So as time goes on, a lot of software projects end up looking like this truck with lots of fancy stuff glued onto it. But other parts of the code don't get used at all over time. And so you end up with stuff like this, that external elements in the environment have changed so much that there are now parts of the code that are completely useless. Nothing in the IT community stands still. And so you have to build your code to be able to change. If it was written so that it cannot change, you cannot maintain it. Also, at the time that you are writing code, your head is deeply in the problem. You have a result that you want to obtain, and you are aware of the edge cases. So you have a write versus read problem. You're writing the software, and it makes sense to you at the time, but then as time goes on, someone else may look at the code, or you may look at the code later, and you've lost all of that context. And because of that, it makes absolutely no sense to you. There's also the problem of turnover and skill variance. On your team, you're obviously going to have different people with different skill sets, different experiences. Unless you really want to work on the same project for the rest of your life, you are going to move on to different projects. And so other people are going to be maintaining code that you wrote. They are going to have different experiences and different skill sets, and different aspects of the code that you wrote are going to be incomprehensible to them. In addition, you're going to have turnover. You're going to have people leave the organization. You're going to have people come back to the organization. All sorts of things like that happen. And in some cases, you can end up in really unhealthy situations where you have a complete loss of tribal knowledge of the software. You have nobody who has any understanding of what it does. In those sorts of cases, it's OK. You can still rely on your excellent documentation and your full test suite. Right? All right, so yada, yada, yada. I've been speaking a lot about application code maintainability. And the fact is there are a lot of other aspects about maintainability, like optimization for performance. That will kill maintainability overnight if you try to optimize it. Lots of other stuff, too. Feature requests change a lot faster in application development than they do in infrastructure development. Lots of other stuff like that. But it has a lot less impact on CM, so I'm not going to get into it. It's also really hard to solve all these problems. So like that baby with the thing, I'm not going to get into it. All right, so now that we've all agreed that all of this stuff is really hard and really treacherous, why not apply this to the servers? Well, first of all, I've got some really, really good news. It is easy. It's easy, guys. Ansible says even a baby can run a playbook. And opscode/chef/chefs.io says you don't even have to know any Ruby to use Chef. So don't worry about it. It's super, super easy to use. Puppet and Salt also have similar marketing. It's super easy to use, and also their product is easier than all the other products. These are, of course, damned lies. And a picture of a baby has never filled me with such rage. Now, it really doesn't matter how easy the tool is to use. Ansible really is a fairly easy tool to use, and you can write baby's first cookbook fairly easily. But it doesn't matter how easy the tool is to use when the task space is so difficult. Let's explore that a bit. First of all, consequences, schmonsequences. All right. Back in April of this year, there were a pair of posts to server fault in which people described accidentally destroying their entire company using a command line based off of Ansible that they accidentally ran rm-rf, no preserve root, foo bar, and foo and bar were accidentally undefined. Who heard about this? Raise your hand. Yeah. It was a meme for a while. At least one of the two incidences turned out to be a marketing hoax by an Italian company that was trying to be like, hey, you should have your servers supported by me. The other guy turned out not to be using Ansible at all and really did destroy his company. Anyway. Point is, I won't get into the details. It was all horrible. Point is, you can do things like this. You have to try a little harder than this. But you can really do terrible, terrible things. The thing is that when an application developer is writing code, they tend to be working with things like, inventory counts or shoe sizes, or maybe at worst, e-commerce, for example. Unless they're in like life-critical applications, which most of us aren't, they're doing things that are recoverable in some fairly fairly straightforward way. Even if you goof up all the transactions for the day, you usually have an audit log and you can roll it back. That may not be the case at all when writing infrastructure code. You are creating servers, you are destroying servers. You are creating backup sets and destroying them. You may be doing things like doing schema migrations. You could be destroying backup servers, reconfiguring load balancers, setting up all kinds of networking, all that kind of stuff. So the consequences are a little bit more severe. Now you might be thinking, what do higher consequences have to do with maintainability? It's a huge psychological burden. Because if you think, if I make a mistake here, if I change this and it's wrong, I could destroy the company, you're going to be afraid to make a change. And if you're afraid to make a change, you're not going to make changes. And if you're not going to make changes, you're not maintaining the code. So code that is too scary to change is unmaintainable. Well, the good news, of course, though, is that the people who are making these changes have excellent training on configuration management and understand exactly the dangers that they are about to get into. No, of course they don't. The people who are doing configuration management work tend to be ops people, at least in the proof of concept stage. Maybe it's somebody who has a grassroots effort of, man, we ought to get some Ansible in here. Or maybe it's from above, somebody saying, let's get config management, I've bought 5 units of DevOps, and now we're going to put them in place. So the people who are doing the configuration management work tend to be ops engineers. Now, that's good news in a way. They've got the right subject matter expertise. They've got the right enthusiasm. They want to automate their jobs more so that things suck less. That's good. But as soon as you start writing any infrastructure code, you are no longer a sysadmin. You are a developer. I am so happy that got applause. That's the main point of this talk. All right. So how many years of experience do you have as a developer at that point? In particular, how strong are your instincts around things like input validation, edge cases, testing frameworks, all those sorts of things that are going to make it safe, that are going to make you not be the little girl staring into the cannon? Now, the good news as well is that there are people in your organization who know exactly such things. They're called developers, and especially they're called QA engineers. So if you've got a dedicated QA department in your organization, go have lunch with them. Have conversations about how things break, how do you test things, what are failure modes, that sort of thing. They're not going to understand at all about how do you break a load balancer, what could possibly go wrong, but the concepts involved in testing are going to carry over very well. It's really good to have a QA engineer as a friend when you're doing this sort of thing. So how do QA engineers do this sort of stuff? Well, one of the big secrets is that you don't have to test things against reality. If you were making a car and you wanted to find out how much horsepower it had, would you get it out on the interstate and try to drag something? No. You would build something called a test fixture. This is called a dynamometer. What this is a thing where you put the car in the garage, you hook its back axle up to some giant things, and you floor it. And you find out exactly how much power is coming out through the back axle. Likewise, when we do infrastructure coding, you can do similar things. You can create test fixtures to help you do this sort of testing. Now, there is a big difference here in that when QA engineers are writing this sort of stuff, they're testing against a single source code file or a library, or it's got unit tests or that sort of thing. You may be setting up an entire a machine with an operating system and configured services, and you have to install the application, and you have to make sure that it's actually working kind of somehow. Or it could be even worse. Maybe you have to set up an entire distributed system with the persistence layer and the load balancing layer and all these other sorts of things and the microservices and all that. The problem is a lot harder. All right. Finally, CM is not good for everything. When you have one tool that seems so awesome, and you're that ops engineer who now has the power of automation in their hands and is using Ansible for everything, you might start to think that you should use it for literally everything. Like, I'm going to install users with this. I'm going to install services and configure them. Great. I'm going to do schema migrations with this. I'm going to do failover migrations and things. Do not do database failovers using Ansible. It's a terrible idea. It is totally technically possible. You can do it. But the point is that there are better tools for this. You don't have to use just one tool for these sorts of things. All right, part 5. Free advice. I've been talking a lot about these various factors that make software maintainability hard, and CM code maintainability particularly a nasty problem. My hope is that you will be able to pick up some of these factors, apply them to your own particular situation, and come up with some ideas to improve yourself and your situation. That said, here are some general things you can do. All right. So at the top, it's cut off. It says comment on why, not what. So this tip is write comments in your CM code. Now, okay, everybody says, yeah, I'm developing now. I'm supposed to write comments. Now, you may be thinking, what's with this choice of image? This choice of image is because you can look at this image, and it is very easy to describe what is in the image, right? Well, there's a skeleton, and there's a French horn, and there's a black cat, and there's a young girl with steam coming out of her ears. Fantastic. Now, someone reading your configuration management code, they don't need a comment to tell what's going on. It's easy to say, oh, you're doing this, you're doing this, you're doing this. The piece that is missing from this image is why. I don't know why. I have no idea. Likewise, someone reading your configuration management code needs to understand why. Leave comments at the level of intent so that someone down the line is able to understand the purpose of what you're doing and the constraints you are under. Next, pre-flight. One of the most basic things you can do to increase safety and make it safer to run and maintain your code is to add pre-flight validations, all right? So this is a close-up of the abort switch from the space shuttle, all right? As they launched the space shuttle, when you take off, you keep that switch in various positions throughout the course of your takeoff, and if things go wrong and you will not be going into space today, you hit the big black button next to it. And then something possibly terrible will happen to you, but it will try to get you back to the ground in some way. Now, one of the things that people may not realize about the space shuttle is that the main engines, the three on the back of the orbiter itself, they ignite about 6 seconds before the solid rocket boosters ignite. Now, the thing about solid rocket boosters, once they ignite, you are committed. You are going upwards. It may not be good, but you are going to go upwards. So you want to have some time to do some pre-checks before you commit to those sorts of things. So they light the main engines. It's not enough lift to get off yet, but it's jittering. And at that point, they're running a whole bunch of tests, and they have one last opportunity to abort. Now, obviously, we never heard about anything like this, so you would think, obviously, this never happened, right? How many times do you think it actually happened? 10 or 15? It was 6. It was actually 6 times they aborted on the launch pad, once with a quarter of a second remaining before igniting the solid rocket boosters. I would need to change my spacesuit if I were sitting in that thing at that time. Anyway, but the whole point of this is, in your configuration management code, write checks. Do things like check every variable that you expect, every attribute, all that sort of thing, anything that you rely on to be A, defined, and B, to have a sane value. Check all of these things before you make any changes. That way, if there's something wrong, you abort the run, and you've made no changes and no harm was done. Speaking of variable storage, don't go crazy with this stuff, man. Put your variables in a simple way. So like Ansible and Chef, they both have ways of storing attributes or variables. Chef went completely wacko with it. There's like 20 different ways of storing them at 17 different levels of precedence. And it's completely mind-boggling as to how to do it. And then there's also a 2-pass execution run. So actually dynamically setting one attribute from another is completely fraught with peril. And if you do it, you will just be simply eaten by dragons. So don't do that. Ansible is simpler, but it is also much buggier and poorly documented. So there's only like 5 ways of storing variables or storing facts or variables in Ansible, and it gets facts and variables confused in various ways. Long story short, your team needs to figure out the one way that's going to work for your team and just do that. Don't go mixing and matching the whole ways that you're storing your variables and all that, because you will have a lot of regret. But how can you enforce that? Well, you can use something called a linter. You might think, oh, I'll just grep through all of the things. I'll just grep through all of the files and look for places where people are misbehaving. But it turns out developers have made things that are a powerful grep called linters. Linters go out and look in your in your files. They don't run them, but they apply special rules to look for things like, you're setting an attribute in a way that's not allowed. All of the linters, there are linters available for all the configuration management systems now. Some of them have really great sets of curated community tool rules, some don't. But all of them allow you to write custom rule sets for your own site. Also, you should write tests and have tests. I wish that I could call this bananas. Like, we should all have bananas. Because if I said to people, go have a banana, everybody would be OK with that. But if I said to them, go write a test, everybody's like, no, I'm not writing a test. Testing's horrible. But in fact, testing is easy. It's so easy. You don't have to do a lot. You can use tools like InSpec or ServerSpec to write super, super simple tests. These would be tests that do things like ensure that Apache is installed, make sure that port 80 is listening. That's all. If you just had one test that said port 80 should be listening, you would gain so much because you would be able to run your convergence. And at the end of it, if port 80 is listening, you know that most things went pretty much OK. You don't know that it actually works. But if port 80 is not listening, you know that something went horribly wrong and you should go investigate. Also, having tests is very important. Having tests is, I would say, more important than writing tests. Because when you have tests over time, which remember, maintainability is all about software over time, when you have tests, you can add a new feature or make a change and then run all the tests again and make sure that everything that you had done before still works. And if you add Postgres and now Apache won't run, you know that you screwed something up. So you need to go back and fix it. That's called a regression test. It's a huge confidence booster. All right. So where are you going to run these tests? You should never run them on anything that you care about. You should also never run them on anything that anybody else cares about. So I would say if your testing scheme is, I have to wait until the QA environment is ready for me to run tests, that's bad. Because now you can't develop and immediately run tests because testing becomes a hassle. You need to be able to control where and when you run your tests in a place that nobody cares about. There's a lot of great ways of doing this. AWS is a great way. Google can do it too. But if you can't get permission to do that or whatever, do it yourself on your own machine with Vagrant and VirtualBox. They can totally do it. So, all right. Also, don't test in production, please. All right. OK, so I've mentioned all these awful tools and linters and testing and test kits and all this sort of stuff. And you may be thinking to yourself, oh my gosh, there's so much to set up, and I'm not doing this. You don't have to. Use a development kit. Most of the CM tools out there now come with a development kit. Chef DK, Ansible DK, these are goodie bags. You go out and you get one, and it's easy to install, and it includes linters, and it includes testing frameworks, and it includes all this stuff. It's all right there in the bag. You don't have to go out and fetch all this stuff for you. It just magically works. I would also say use a code generator. Both Ansible DK and Chef DK contain code generators. A code generator is a thing that you run it whenever you need a new cookbook or a new playbook or that sort of thing. And it does all the boilerplating for you. Now you might think, oh, I don't want to do it the way Chef wants me to. Great, don't. Make your own cookbook generator or your own playbook generator. These things let you make your own things that apply to your site so that you can say things like, when I create a new project, every time that I make a git commit, it should immediately run the linter before trying to push. You can totally do that. You can set up your own hooks. And then that way, once you have this in place, and I know I'm only speaking to the smart, senior, elite people in the room. Once you have set that up, all your junior colleagues will have all of these things by default, so that everybody gets a level set in terms of what's expected. So a new person to CM sits down and is like, oh, I'm going to do this thing, run the code generator. Oh, naturally, I expect that testing's a part of my life, and linting is a part of my life, and all these sorts of things. The expectations are already there. Likewise, in terms of level setting, use code reviews. I assume you're using Git or something like it, some sort of version control. If you're not using version control, look into it. Use version control, ideally one with a web UI. GitLab, GitHub, Bitbucket, they've all got this sort of thing. The idea behind a pull request, some people, the initial view of a pull request might be, oh, it's a control thing. This allows the maintainers to gate what gets into the project. And initially, I mean, it does have that effect as well. But that's actually not the most important impact of it on a team. The most important impact of code review on a team is that you're able to share things with each other and communicate about the code and the changes that are going on. Your most junior people can look at the code and see what's going on, and your most senior people can review what's going on too. Something that some teams even go so far as to do is to have the junior people, as part of the code review, explain the changes. And if the junior people can't explain the changes, and this, you have to be kind of careful about this because you don't want it to become your skills aren't high enough to do this yet, or that sort of thing. It has to be carefully handled so that it's very clear that the code should be clear enough so that everyone on the team can understand it. And if the code isn't clear enough, it needs to be either clarified or reconsidered. Because if you're doing something completely insane, like doing a 9-level notification chain in Chef or something like that, why are you doing that? You shouldn't be doing that. There might be things like database failover between machines in Chef. You definitely should not be doing that. So anyway, all right. Another thing to consider is simply to burn it all down, all right? It's configuration management code. This isn't application code. It has a short lifetime and a smaller code base. The longest lived CM code I personally have ever seen is 3 years old. Application code, 40. So that's a big difference. If everything in your code base for CM has become awful, burn it down. It's not nearly as much work as you might think. Also, it's relatively easy, compared to other problems, to have some groups of servers using a new workflow and another set of servers using an older workflow. So be prepared to burn it down, lower that barrier. Also, you might consider really, really burning it all down and abandoning CM entirely. The day may come when you say to yourself, I no longer need Chef, I no longer need Puppet, I no longer need any of these things. Why? Perhaps your company has moved to a container-based system. And if that's the case, building your initial image might look very different. You no longer need the ability to manage changes on a long-lived machine over time with incremental changes. That's what configuration management is for. It's for maintaining pets over long periods of time. The community now agrees pets are a bad idea. So if you are moving beyond pets to perhaps an immutable infrastructure or some sort of container-based system, or if your developers have even said, we're going to drink the serverless Kool-Aid and that's the direction we're going, the need for CM may have left your organization. Fine, roll with it. Tools change, that's okay. All right, that's all I got. Went a little over, sorry about that. On that happy note about configuration management, I don't think I have any time for questions, but if you do want to talk about any of that stuff, I think there's a lot there to talk about in open spaces. So.
You do have about 8 minutes for questions.
I have 8 minutes for questions? I thought I was up against a break. I went for 32 minutes. Awesome.
No, we started you early.
Okay.
Unless you don't want to take questions.
I will totally take questions. Let's do
I
it.
thought that was a way for you to dodge it.
I was not dodging it.
Oh, we
no.
don't have time.
You'll have to talk to me in open spaces where I don't have to be.
Questions. You going to make me ask the first question again? Oh, here we go.
I just want to hear about the abort sequence that almost blew up. 1/4 second before the solid rockets were ignited. Do you happen to know?
Yeah. That was STS-51F. Nerd. I believe that was a classified mission, but I know which shuttle it was. Guess.
Challenger?
It was Challenger. Yeah, it was Challenger. That was not the STS-51 was not the one where it later had another incident, but that was Challenger. Yeah. No, it was. I believe that was a turbo pump sensor failure. Is what that was, and they fixed that one on the pad. Sometimes when there's a problem on the engines, they will roll the whole thing back to the VAB and replace an entire shuttle main engine, which is obviously involves weeks. In that case, that just I believe required a day or two of service. So, but they had some crazy aborts. If I could get in, because I love talking about this. So. What I'm talking about is the first one called the RSLS abort, which is you never leave the pad. The most insane one was called the RTLS, Return to Landing Site Abort. They never had to do this, and thankfully. But so here the problem is the boosters have ignited. You are attempting to go to space. You're starting to clear the tower, and something goes wrong with one of the main engines, all right? At this point, you do not have enough energy in you to make it to orbit, all right? But you have way too much energy to do other less crazy things because those solid rocket boosters are full of energy and they want to go somewhere. You also can't just pop them off because they're going, there's Florida. So,
Would that be a loss?
I know, exactly. But, they have senators and they vote and fund things. And so anyway, so here's the plan, all right? We're going to go up and over the Atlantic Ocean for a while, all right? The SRBs are going to burn out. We're going to pop them off over the Atlantic Ocean. But we still have got an external fuel tank that's mostly full at this point, and we have 2 engines, maybe only 1 engine working, so we're not burning fuel as fast as we should. And the shuttle didn't have a fuel dump. You can't just start dumping fuel out the bottom of it or something like that. The only option is to eject the entire external fuel tank. So anyway, you're flying over the Atlantic Ocean, so you roll over with a giant heavy tank under you. And remember, you're not a real plane. You're a shuttle. You're a glider. So you roll over and you turn around. And you come back to Kennedy is the idea. And at some point, before you get to the Bahamas, you drop the tank because the tank should be empty. And at that point, you're able to glide into Kennedy. And John Young, who is the commander on the first, on STS-1, the first flight, said, an RTLS abort scenario requires a constant series of miracles and several individual interventions of God in order to successfully be pulled off. So
Sounds like config management.
it does, yes. Actual questions related to the talk.
Yeah. Other questions? About 4 minutes. Yes.
So with everything that you've said, what is the config management tool or tool sets that you choose to use the most in your normal operations?
Well, as a consultant, it depends. That's it. Seriously, I work with clients, and so typically I'm going into a situation where they already have a tool. They've already gotten on board with Puppet or Chef or Ansible or something like it. And our goal there is to improve the campsite, make things better. So that's what we tend to do. If it really is totally greenfield, then we sort of evaluate who the people doing the work are. If they are developers, if we have an integrated service team that's going to own a service and they're like, oh yeah, now we need to understand config management, then we typically say Chef, because Chef is a more developer-oriented type thing. There's a lot of thinking behind it that's very object-oriented, the way that you reuse resources and things like that. If it's more operations people that are doing it, we tend to start off with Ansible. They have different learning curves. Ansible's much faster to learn, but you hit your ceiling much harder. The limit of things that you can do in Ansible is so much lower. It gets so hard to do complicated things in Ansible. And that's kind of a design feature, that maybe you shouldn't be doing complicated things in Ansible or any config management. So I am.
So you mentioned code linters.
Yeah.
I'm curious if you wanted to expound upon how much you should use code linters and how much you shouldn't use code linters. Hint, I learned about nonviolent communication due to code linters.
Yeah. It gets into the whole coding standard group consensus around who are we, what are we building, how much do we, how important is the quality of our code base to us. And there's things like Food Critic, there's Ansible linter, there's RuboCop for general Ruby development, there's a YAML linter out there as well. There's a lot of different things that can do this. And what it really comes down to is how much value is a particular rule adding to your organization? So if you've got a rule, like what I talked about variable storage, I think it's super dangerous to do things like overrides in Chef. You should not be doing attribute storage that says override this by default. Like that should not, you should not be reaching for that lever. If you're reaching for that lever, something has horribly gone wrong. So having a food critic rule that searches for override level definitions of attributes is probably a positive thing. If, on the other hand, if you have one that's like searching for single quotes versus double quotes, I disable the crap out of that thing in Robocop because it's a waste of time. I mean, it's just like, it's maddening to me. And if I find that there's 2 people on my team that are really mad about it and 2 people that are like, I don't really care, I'm like, let's turn it off. That's fine. But it's going to evolve over time. And if you just keep coming back to business value about it and just keep reminding everyone, it's okay, we can change these things. It's a negotiation. Questions? The unicorn approaches. Oh,
The unicorn
there's one
approaches.
There's
Yeah,
one
we'll
more.
have to take it in open spaces.
All right.
Or grab Clinton afterwards.
Big hand for Clinton. So Clinton, have you ever hugged a unicorn before? Thanks so much. Another hand for Clinton. How awesome was that?